Again, good morning, everyone. I'm Douglas Cirqueira, and I have as supervisors Dr. Maria Brisbaditza and Professor Marcus Heffert. The title of my transfer presentation and work is a reference process model for explainable AI in fraud detection. So this is the brief agenda for my talk, which covers the main topics of my work as the research motivation and problem, as well as the methodology and results to date plus next steps. So starting with the motivation for my research, banking and retail industries, they have invested in the adoption of AI-based fraud detection systems to support experts in analyzing suspicious fraud cases and protect their customers from transaction frauds, which grows actually every year. However, such experts, they also need to trust the AI predictions to rely on them for this critical application in which their mistakes might incur in financial damage for customers and also those institutions. So with that, the research field of explainable AI develops a diversity of explanation methods which provide particular explanations for those AI predictions. In this context, an explanation gives the reasons for an AI predicting frauds. For example, an explanation could refer to the strange location of a current customer transaction. However, a question remains, which is if those experts, they trust those predictions and explanations enough to rely on and use them for protecting customers. So that's actually the motivation for recent literature emphasizing user-centric explainable AI frameworks. Those frameworks try to align the requirements of experts to use particular explanation methods, aiming to ensure their trust. However, it's a complex task to align experts' requirements with this diverse set of explanation methods, because they have particular capabilities and features, and those experts have a particular domain background knowledge to define which tasks they are taking for analyzing particular cases. Given this context, I adopt an information systems theoretical lens, which has considered for years the relationship between users, their requirements, and their systems that they are using. This lens will help me in tackling my research focus, which is to understand how to align fraud experts' requirements to instantiate appropriate explanation methods within an organization and ensure their trust in those AI predictions. So regarding related work and research problem, first, during my literature review, I tried to understand how existing user-centric explainable AI frameworks define the requirements of those experts to align with explanation methods. In the static context, researchers define particular dimensions to those requirements, such as what, who, why, where, or when to use an explanation method. This is described as an static perspective, as it considers the single question and answer approach for providing experts with explanation methods. On the other hand, when adopting an IS lens, I can perceive the alignment between those experts' requirements and explanation methods based on a process perspective, which means to consider their decision-making tasks for alignment with the explanation methods. So based on this theoretical background and lens, I expanded my literature review, which I present through my review table with a representative sample of studies from my literature review. So this literature was classified in 3 themes: user-centric explainable AI frameworks, visual analytics studies, and explainable AI studies supporting experts in fraud detection. I take my IS perspective to organize my findings in the table. So first, I started by understanding the perspective taken by previous authors when identifying experts' requirements. Second, I analyzed if those requirements were aligned specifically with explanation methods. And third, I investigated if such relationships were considered under the scenario of transaction fraud, which is the focus of my research. Based on that, the first problem I identified refers to the perspective adopted by existing user-centric explainable AI frameworks, which is actually static and does not reflect their tasks for dealing with explanation methods and AI predictions. The second problem illustrates existing explainable AI empirical studies have not identified experts' requirements for explanation methods, which is characterized as a lack of user-centric perspective in this regard. So based on such studies and frameworks, I came up with my the identification of my research problem, which is the lack of trust of fraud experts in AI models for decision making, who have low confidence in adopting their predictions for reviewing fraudulent cases, given that their requirements are not reflected by explanation methods they would use. So based on these findings and problems, I formulated my hypothesis, which states that the trust of fraud experts in AI models can be mediated through appropriate explanation methods following a process perspective in their requirements for reviewing fraud cases. To provide the explanation methods in a process perspective to fraud experts, my research goal is to develop a process model guiding the instantiation of explanation methods to those experts. The process model itself will be an abstraction to better structure a trustworthy fraud detection process supported by explanation methods. And to develop this process model, I have 3 research questions, which will help me in identifying the elements to compose the model. So first, to identify the requirements of fraud experts regarding explanations of AI predictions, with the goal of assessing which methodology to use for identifying those requirements and the decision-making tasks of experts. Second, I'm investigating what are the requirements of the diverse set of explanation methods, what are the features of this diverse set of explanation methods which are existing and that can be adopted for the differentiation and instantiation with this process model. Third, I'm investigating actually how to design and evaluate the process model which will integrate the requirements and the features of the explanation methods for promoting fraud experts' trust in AI predictions. For answering those research questions, I present the research methodology I'm adopting next, which is a design science research methodology. And the reason why I choose this methodology is because my research tackles the complexity of aligning a diverse set of explanation methods to requirements of fraud experts dealing with a critical application. And it's complex to uncover such requirements as they depend on the operational context and experience of those experts in fraud. Design science research deals with wicked problems, which indeed relate to my research and to this complexity. And even if you have a complex environment to work on in your research, this methodology provides you with clear steps to identify the problem, define the objectives of the research, and to develop and evaluate an artifact for solving the identified problem. Furthermore, the process model will be developed in close interaction with practitioners, and I will have iterations to assess its reliability regarding the trust of experts in explanation methods. So this methodology also guides researchers when working through iterations and also interactions with practitioners. So the methodology I'm adopting is composed of 8 activities, and currently I'm in the meta design and artificial evaluation activities, mainly developing my evaluation design within this phase. So based on this methodology and research questions, I present the results obtained so far. I start with results from my first research question, which asks what are the requirements of fraud experts regarding explanations of AI predictions? And after investigating methods for requirement solicitation in explainable AI, I choose the methodology of scenario-based requirement solicitation, which is introduced in the literature by Wolf in 2019. And indeed, I can mention some researchers such as Hetsu and Carroll, which are among the pioneers in making use of scenarios, because they argue that scenarios can bring an HCI and user-centric perspective for information systems development, which again matches my the theoretical lens that I'm adopting in my research. So the scenario-based method is actually a problem-centered approach for identifying user needs early in the development of information systems. And to use the method, I did problem-centered interviews with 3 experts in fraud within Austrian Bank. Those experts have a minimum of 3 years of experience in fraud analysis, and 2 of them have more than 20 years in the field. I asked them about their current settings, goals, and tasks, as well as tools capabilities with the aim of creating fraud detection scenarios. The interviews lasted for approximately 1 hour each, and I was facilitating the discussion. So based on the implementation of this methodology, I discovered 2 scenarios and their tasks. So I have identified 10 steps those experts usually follow when analyzing a suspicious fraud case. For instance, they analyze similar cases to a current transaction and the impact of each attribute in that transaction, which their system has used for providing them with that suspicious case. However, I also wanted to generalize those tasks based on the literature. And when following design science, you can see that the methodology guides you to ensure relevance from the practitioner's perspective on the problem, but also rigor from literature findings. So in order to have rigor for these findings, I did a systematic literature review to verify the presence of those tasks in the literature of explainable AI methods and visual analytics supporting users' decision-making. I started with identifying relevant keywords and databases for my literature search, for which I collected 1,310 papers. And I filtered those papers to come up with 367 potentially relevant papers, from which I ended up with 52 papers focused on decision-making support with visual analytics or explanation methods. Then I have found, out of the analysis of those papers, 13 key tasks. I also add the requirement derived from each task to generalize its meaning for fraud analysis. And the importance of those tasks is actually, they're essential for my research, as they reflect the real decision-making process of fraud experts. And it was a challenge to get to those tasks, as those experts, they are usually immersed in this environment with their particular experience on how to analyze fraud cases. So those tests are valuable because they provide a normalized view into this decision-making process, which would allow a researcher to design explanation methods with a user-centric perspective. This is actually in line with my underlying hypothesis, stating that the trust of the experts when having explanation methods aligned with their decision-making tasks would potentially be ensured. So those tasks will be part of my process model. And my next step was to discuss those tasks with the experts. And I found out that 9 of those are comparable to the decision-making tasks. For example, to analyze similar cases, the importance and impact of attributes in predictions or of fraud detection systems, which are also tasks that they are performing. It was also interesting when they said the ones not present in their scenarios are available for their analysis, although not being executed due to limitations in their current fraud detection system. So those tasks and the scenarios discovered through the implementation of the scenario-based method, they were published in the CDMake XAI conference this year. Then, continuing here, So from the first research question, I identified the decision-making tasks. However, to develop the alignment between those tasks and the explanation methods, I need to answer my research question 2, which asks, what are the features of explanation methods for their differentiation and instantiation? To identify and classify those features, I did another systematic literature review by first analyzing surveys and taxonomies to obtain meta characteristics to develop a taxonomy of explanation methods. So for that, I started with 2,515 papers collected, which were reduced to 287, discussing classifications. And I ended up with 167 papers really discussing classifications within the explainable AI literature. So based on those papers and following the methodology for taxonomy development from Nickerson, first I have identified 4 core categories which are used for mapping explanation methods, such as influence, case, sensitivity, and inference-based categories. Then after analyzing the 167 papers, I came up with 12 explanation methods, which are illustrated in this taxonomy. I stopped increasing the taxonomy based on the objective criteria of no new dimensions being added when I was analyzing papers, discussing explanation methods, and on the subjective criteria of comprehensiveness. When I get a random sample of papers and I try to classify the explanation methods in those papers under my taxonomy. So different from existing taxonomies of explanation methods, the value of my taxonomy is that it brings this classification based on decision-making tasks identified in the literature analyzed. Therefore, its value is in summarizing explanation methods in this abstractive perspective for which other methods can be mapped as well and aligned to the tasks of the experts. For this alignment instantiation of methods to work, I have identified 5 key features of those methods, which are the scope, dependency, target, interactivity, and question capability. So based on those features, the explanation methods will be embedded in my process model. And I can give the example of one of those activities, which is to analyze similar cases. So to analyze similar cases to a suspicious transaction, an expert can be supported, for example, by a case-based explanation method, providing representative instance of a particular class, or adversarial examples illustrating cases that the AI model can get wrong. So given the results from my research questions 1 and 2 presented, the next results regard the development of the process model itself, which is within my research question 3. So for that, I have developed a meta design with the identified requirements and decision-making tasks of the fraud experts together with the classified explanation methods in the taxonomy. I use the Archimate language for modeling this meta design, and the aim is to enable fraud experts to reflect on their own decision-making tasks and requirements and understand the capabilities of explanation methods aligned with those requirements. So in between tasks and explanation methods, it should be developed the process model representing the outcome of my research question 3. Then from this meta design, I have designed a process for validating with fraud experts during my evaluation steps. And I did that by selecting some of their tasks for decision-making based on the identified scenarios from research question 1. As you can see, the process model actually guides the instantiation of explanation methods in a process perspective to fraud experts. The instantiations are depicted in the interface, which fraud experts can use to analyze suspicious cases and make decisions. And in this particular case, they would, for example, first check the ranking of suspicious cases and select the most critical according to the prediction probability of the AI model. Next, they would analyze similar cases to the current analysis following to the most important global features that they are considering for, that the AI model is considering for providing predictions, as well as rules and local important impactful features for those predictions. So regarding the implementation of this interface, I used the Python programming language version 3.8 and some libraries for machine learning models, as well as existing explanation methods libraries to instantiate those methods. And finally, for evaluating and updating those results through iterations, I have defined an evaluation design. And indeed, the design science research methodology I follow also guides this evaluation design for my artifact, which is the process model, and also the results of my research questions 1 and 2. So here you can see the inputs for my evaluation process, and you can also see that I have 2 phases for evaluating the requirements and features of my research questions: an artificial and a naturalistic evaluation phase, in which I'm adopting particular methods. My goal in the end with this evaluation design is to provide as results an useful process model to instantiate explanation methods to fraud experts, which will be validated by simulated user trust, the validity of the constructs within the process model, and the trust of experts instantiations guided by such model. There will be room for iterations to update my inputs and process model according to the results and feedback from fraud experts during my evaluations. Finally, given I will assess the trust of users into explanation methods, it's important to define a model for this assessment. And for this definition, I reviewed existing models for measuring human-computer trust, which I can use to validate my process model. With a particular criteria for selection based on this suitability of each model to my context, I selected Hoffman, which has the factors of reliability, technical competence, understandability, faith, and personal attachment of a user to a computer or a system, or in my particular case, an AI model. I will adopt this model to collect data through a 7 Likert scale and a think aloud protocol during my user experiments. That's because I'm not taking a purely quantitative perspective in my research, but I also want to inductively understand the approach, the appropriate explanation methods for the decision-making tasks of the experts, ensuring their trust. Another point to mention is that currently the European Commission for the Digital Future Strategies is developing ethics guidelines for trustworthy AI. And I personally think it's essential to consider such a reference in this project, because I wanted to make sure that the requirements stated by that working group, they are also reflected in this model that I would use for assessing trust of experts in the explanation methods guided by the process model. Indeed, by looking to the factors here, we can refer to, for example, the requirements of human agency and oversight, technical robustness and safety, as well as transparency requirements, which are stated by the EU guidelines. So as future work, I have to perform further iterations with the results from my research questions with the practitioners I'm working with, and also to finalize the design of my artificial evaluation steps and the models I'm using for assessing the trust of the experts, as well as another thing that I didn't mention, which is the quality and validity of the constructs based on an information quality framework I'm using. I'm also working on the implementation and instantiation of explanation methods. So as you noticed, I have 12 types based on my taxonomy. I have to finalize the implementation of those. And I aim also to obtain a larger data set from my partner for further publications and experiments, as well as to demonstrate the process model in banking and digital retail cases, followed by the naturalistic evaluation, which will come further. So as contribution, I wanted to recall that the core focus of my research is to develop a process model for the instantiation of explanation methods to fraud experts. The aim is to promote the trust of those experts and confidence of organizations adopting AI models for fraud detection in their daily operations. And the process model will enable experts to rely on and reflect on a model which has their decision-making tasks for fraud detection and also information on the explanation methods that they could use for those tasks. Currently, experts can reflect on 13 decision-making tasks as requirements for explanation methods, which are classified in 12 types with 5 features for their understanding. Some researchers also recognize that human trust is mutable. It's not a static construct. So I believe that this process perspective I'm taking my research might be able to capture these characteristics and help other researchers in dealing with such aspect. There is also a debate in the Explainable AI community on how to take into account user needs for developing explanations. And I believe that taking these information systems perspective, as I'm doing, can support and shed light on that direction, particularly in the domain of fraud detection. So I would like to acknowledge the funding bodies for my research as well as research centers involved. And I also wanted to highlight my research schedule to achieve the goals of my project, which covers all the activities with my research methodology. And as I said, currently I'm working on the design of my artificial evaluation process and for my iterations with the practitioners. So this is to also an expanded version of my current transfer report, as I had to shift timing because of challenges to get to talk to those experts due to social distance measures in this current time. And I also show the publications along my PhD journey so far. I had 3 publications, and the latest refers to the validation of results within my first research question, which are the scenarios and the decision-making tasks of those fraud experts. I also have an outline of my next publication targets connecting to my thesis results, as well as targets for those. And with that, I end up my transfer presentation. I would like to thank you again for your attention, and I'm very grateful for all of you that are being part of this today. So thank you very much.